Hello and welcome back to the CCENT journey with me, Ryan. In this section we're going to continue with the routing part of the ICND1 or CCENT, and we're going to dive a little bit deeper into dynamic routing. In the last video we talked about static routing and we configured some static routing. In this video we'll do the same for dynamic routing. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. So let's start with having a discussion about dynamic routing. And this is going to be a very high level discussion because as the videos progress in the routing section, we're going to cover dynamic routing in more depth, especially when we get on to understanding the routing decision. Unlike static routing, which the majority of it can be picked up in a single video, dynamic routing is a bit more complex. However, for the ICND1 and CCENT, we need to be aware of the dynamic routing protocols and the different types that we have. But primarily we need to be fully aware of RIP, the Routing Information Protocol. Now in this particular video we're going to have a look at dynamic routing as a whole and why we might use it over static routing, and look at the configuration and verification examples, and then we'll jump into packet tracer just like we did with static routing, but we'll configure some dynamic routing instead. So let's go on with the slide, and then after the slide we'll jump onto the hands-on. So dynamic routing, unlike static routing, we have multiple options. So in the previous videos we talked about the differences between an IGP and an EGP, and we talked about IGPs are things like RIP, EIGRP, OSPF, and as I said many times before, we need to be aware of OSPF and EIGRP, but we need to be able to configure RIP. And the reason we need to be aware of these is because we need to understand as engineers the routing decisions a router may make. So for example, why a router may choose a OSPF route over a RIP route. And that routing decision and order of operations we picked up in the next video after we've had a quick talk about dynamic routing. In the last video we went over static routing. We said that static routing is a way to essentially tell a router how to reach a remote destination. So for example, if we had the 192 network off the back of this router, we would instruct this particular guy, if you want to get to this network, go to this next hop, or in some instances go to this local interface. And then that enabled us to have some form of routing between the two devices. Well, dynamic routing obviously bypasses this reason to have any static or any admin overhead, and allows the routers to communicate to one another and to advertise the routes that each router knows about in order to have end-to-end reachability without an administrative overhead. So the ADs and metric. AD is something we talked about when we did talk about static routing in the last video. We said that static routing has an AD of 1. We didn't go into metrics because static routing kind of doesn't work with metrics, and we'll get into understanding why that is in the routing decision. Why it is important with dynamic routing is because, as I said, that we have multiple options when it comes to dynamic routing. So if a particular router has multiple ways to reach a particular destination, let's say it has a RIP way and it has OSPF, and inside RIP it has 2 paths, and inside OSPF it has 2 paths, the router first needs to pick which protocol to use. Does it use RIP? Does it use OSPF? And then once it's picked the actual protocol, which path within that protocol does it choose to use? Does it use one with a particular cost, or does it use one with a particular hop count? So the metric and ADs, along with other options, gives the router the ability to make the correct decision, and in turn allows us as administrators, as engineers, to have a lot of flexibility when it comes to building our networks. So we need to understand a few things. First, we need to understand why there are different metrics per dynamic routing protocol, why there are different ADs per dynamic routing protocol, and why having different metric and ADs decides which path we take. And as engineers, we need to be able to look at a particular routing table of a bunch of entries and determine why this entry is being referred over this entry. And that will all come together once we've had a talk about dynamic routing and seen it through Packet Tracer, and when we've looked at the previous videos about static routing and the videos before that to understand why routing is needed in the first place. Bringing that all together and understanding the order of operations will help us as engineers understand the path selection that our routers take to enable end-to-end reachability. So different ADs, different metrics depending on the routing protocol. I said it multiple times already, we need to be aware of all protocols. And when I say all, what I do mean by that is BGP, not so much for the CCENT, but it doesn't hurt to be aware of it. I would say things like EIGRP and OSPF are your main two that you need to be aware of, and you need to better configure RIP, the Routing Information Protocol. And there'll be separate videos on RIP, how it works, and some of the additional options we have of RIP, like understanding which version you would use and why, understanding the auto summary, and how we can look at the routing table, modify hop count, and so forth. And it dynamically learns, adapts, and resolves. So remember previously we had a good flaw with static routing where if we had a switch in the middle connecting, let's say, two routers together, and this particular router had an IP route statement, remember that's the command for a static route, to say if you would like to reach the 10 network that sits behind this particular router, go to this next hop, but the router end-to-end reachability has died, but because the link here to here is up, the route still gets installed into the routing table and traffic gets sent, but ultimately it's dropped. Things like this don't happen when we talk about dynamic routing, at least not normally. And the reason for that is because the routers have some sort of keep alive mechanism or some sort of neighborship in some scenarios between each other in order to verify their existence and verify that the path to the particular destination is valid regardless of what's happening on the lower layers. And if a link were to go down and the routes were lost when the path comes back up, the routes will most likely be installed into the routing table and reused. Hence the dynamic element of it. So some real basic example here of RIP routing. So previously we would go onto the config, and for static we would type IP route. We would then type in the destination network that we wish to get to. We would then type in the destination subnet mask. So let's say for example this is the 10.0/16 network, and then we would normally type in the next hop IP address. Well, with RIP in this scenario, or with any routing protocol to an extent, we would go to config terminal, we would use the command router, and then we would select the routing protocol we wish to use. Again, the only one we need to really be aware of is RIP, and what I mean by that is we need to be able to configure RIP. Once we've gone into the routing submode, you'll see that the command will change to say config-router, and then we can pop in our network statement. The network statement is a statement that says you need to match a particular interface. So say for example we have this interface over here running 10.0.0.0.1, and over here we have 192.168.0.0. Well, this tells, let's say, router RIP. This network statement underneath router RIP tells the router to enable RIP on this interface and start sending out RIP advertisements. It will not be enabled on this interface. And then if we were to enable it on a router over here, let's say maybe on this interface, and they're connected, then it will start to send RIP routes back, and then together they'll be able to reach destinations that potentially sit behind each other. And that's what we'll see in a moment on Packet Tracer. We can also do other things, like we can change the version. So this is changing it from RIP version 1 to RIP version 2. And we'll go into the details of the differences between them. I'm not sure whether RIP version 1 is actually still on the exam blueprint, so we need to go check that out. But it's important to know the difference anyway, and the reason for that is because it helps you understand the difference between multicast and broadcast. It helps you understand why we need to evolve from classful to classless routing, and understanding the background of why something is where it is today helps us as engineers troubleshoot and understand the technology more in depth. And then lastly, some sort of verification, and there are a lot more verifications when it comes to dynamic routing. And again, it depends on which dynamic routing protocol you're using. But what we can do is we can do the show IP route, which shows us the routing table. And just like we've seen with static routing, where we put the keyword of static to only show the static outputs, we can put the keyword of RIP, OSPF, EIGRP, and many, many more. And this will show us only the RIP routes being learned, only the OSPF routes being learned, and so forth. We can look at a specific route in the routing table and its mask. So maybe we've got 192.168.0.0/24 in our table. If we were to pop that in, it would tell us how that route got into the table. It might say it was learned via RIP and it has a hop count of 4. And if we were to try to get to it, we would send our traffic to router 3. And then we can also look at show IP protocols. This shows us the protocols that we've got enabled on the router, and it's a very good verification tool. As far as the CCENT and ICND is concerned, it's a good tool to understand which routing protocols we have turned on, and some of the generic settings about that protocol. Maybe things like timers, maybe things like which interface it was enabled on, and who are we learning routes from. Okay, so here we are, we're in Packet Tracer, and just to take you through the network, just very briefly, this was very similar, if not the same, as the network we used in the static routing example. We've got two routers, router 1 and router 2. They're connected with a /30 with .2 over here, .1 over there. We have a network that all these devices are part of, which is the 172.16.0.0/24. We have .1 is the PC, we have .2 over here, and 254 as the gateway. Same is true over here, .1, 2, 254 as the gateway, but a different network of 192.168.0.0/24. Now the problem we've got, just like in the why we need routing video, this router knows about its directly connected networks. It knows them as a C in the routing table, which is connected, and it knows this network of the 10.0.0.0, and it knows the 172. It's not aware of the 192 network. This router is aware of the 192 network, aware of the 10 network, but not aware of the 172 network. So in order to get this PC to be able to ping across to this PC, we need to ensure that these two routers up here have end-to-end reachability. In the previous video, we've done that by adding static routes to both routers. In this video, we're going to enable RIP, do some basic verification, and then we're going to look at how that differs from the routing table versus static routing. This is not the video about RIP. We're going to have a separate video about RIP. This is just to get us understanding the differences between dynamic and static routing, before I have a video around the router decision and understanding routing process in more depth. So before we get started, let's just jump into a router and have a look at the routing table and confirm what we know. So again, I can do show IP route and I can filter it based on a particular way a route was learned. So show me the routing table only for RIP routes, show me just the connected routes. If you leave it with no argument, it shows you the entire table. And we can see, just as I explained, we have two entries. We have connected entries, which is the 10/30 network that's on the gig 00 interface between router 1 and router 2. And we have another connected, which is this interface down towards the 172 network. The L's are what's called local routes, and this is essentially the IP inside the network that's locally assigned to the interfaces. This means that if I send a packet to 10.0.0.1, it will be punted up to the CPU of the router. If I send it to 10.0.0.2, it will fall inside the /30 and be sent out of gig 00. So we know that router 1 will not be able to reach the 192 network simply because it doesn't know it. So instead of using static routing, let's go for the dynamic approach. And what we're going to do is, first of all, we're going to enable RIP. And to do that, just like as the slide shown, we need to go into the config terminal. From the config terminal, we're going to use router, and if we hit question mark, you can see that Packet Tracer supports a few options here for us. We have BGP, EIGRP, OSPF, and RIP. So for us at the moment, we want to configure RIP. So we're going to type RIP, and hit question mark. We can see that it says carriage return, which means this is a valid and finished command. If we now press question mark inside the config router, we have some further options that we can configure within the router RIP submode. We can do the auto summary, create a default network. We can look at the distance, so change the admin distance. We can obviously exit to go back up to config mode. We can hit network to enable routing on a particular IP network. We can no, so no removes the command. So let's say we set up a particular network. Let's say we done network 172.16.0.0. We can then know it by deleting it. We can do things like passive interface. We can redistribute. We can change the timers. That's how often RIP packets are sent outside a particular interface. And we can control which version that the RIP process will use. Again, version 1 versus version 2. So most of this is inside the scope of the CCENT and we picked up in later videos. For now, let's keep it basic just so we can get a feel for dynamic routing. So what we're going to do is we're going to type network because we want to enable RIP on a particular IP network. And in this case, we want to enable it on two networks. We want to enable it on the 10.0.0 network, which is the link between router 1 and router 2. And we would also like to enable it on the 172.16.0.0 network. So let's just hit enter on that. Now we can verify the configuration by doing the show run router RIP, and the beg says begin. So we want to begin where you see the command router RIP, and it's gone through the running config and it's shown the configuration that I've popped in. What I also want to do is change it to version 2 and turn off auto summary. And now I can see that version 2 is being enabled and auto summary is turned off. And I'll go into detail of what this means a little later. So now we've enabled RIP on this device. We can also verify it by not only looking at our configuration, but looking at the correct verification commands. Now if we do the show IP route, we don't see anything in the routing table, because even though RIP is being sent out of this interface and this interface, we're not learning anything, so therefore there's nothing new to install in our routing table. If we do the show IP protocols, we can confirm that this router is indeed running the RIP process. We can see it's running RIP. We can see every 30 seconds it's sending out updates. The next one is due in 19 seconds. We can see a lot of information here regarding the version, the flush timer. We can see which interfaces RIP is being sent and received on, and which versions. We can see which networks we've enabled RIP for. We can see things like what is the default distance, and if we're learning any routes from anywhere else. So at the moment, it's very basic. We've got RIP data being sent out of this interface towards our host, and data being sent out this interface towards router 2. So now what we need to do is jump across to router 2 and check the existing configuration and then enable RIP. So I've already gone ahead and enabled the enabled the interfaces with the correct IPs. And if we look at the show ARP, you can see we know about our own ARP cache. And if I ping, let's say, the other end here, we'd lose the first ping from the ARP process. And if we look at the show ARP, we can now see that we have the layer 2 address for router 1. If we say show us the running config but begin where you see router RIP, it comes back empty because router RIP has not been configured, nor has any other IP protocols like OSPF, BGP and so forth. So let's go ahead and configure it. We go into router RIP. We're going to pop the version 2 and no auto summary. We're going to turn it on using the network 10 statement between router 1 and router 2. And we're also going to enable it on the 192 network just down here. So now let's go back to the verification. Something very similar to what we've seen previously. You can see again a bunch of information regarding the RIP process, what networks we're routing for, but look at this. We now have an entry in the routing information sources. This tells us that we have a gateway in RIP of 10.0.0.1. So that must mean that someone, in this case 10.0.0.1, is sending us some kind of RIP route because RIP knows it as a particular gateway. So now if we press show IP route, you'll also notice something very interesting in the routing table. We'll see this new legend, or this new symbol if you like, or it should be code I guess, called RIP, which up here is R for RIP. And it tells us that we know how to get to the 172.16.00/24, and we know how to get there via 10.0.0.1, and we know 10.0.0.1 is reachable through this connected, which is on gig 01, which of course is the router at the other end of the link where the 172 network sits. We can also see that we have these two variables that we've yet to see. We have 120, which is actually the administrative distance, and we have 1, which is the metric, and in this case the metric for RIP is what's referred to as the hop count. So in this case it's saying that the hop count for the metric of 172.16.00 via 10.0.0.1 is 1 hop away. And we know that's the case because of course we have a very simple topology, and it is 1 hop to get to the next hop in order to reach the network in question. If we then go across here and we just hit up, you'll notice previously we didn't have any routing information sources. Now we do. We have router 2 sending us some sort of RIP route. And if we do show IP route, we have a new entry down the bottom here. Again, out of the 10.0.0.2 as the next hop, which is the link between the two routers. And this is a RIP route for the 192.168 network. What this means now is that the routers know how to reach the networks behind each other, and they know that through the RIP process. Because we enabled it on this interface and this interface, both routers were able to see the RIP information being sent to one another and install the routes they had to those particular networks. So now if we were to go to PC1 and do some sort of end-to-end connectivity, so let's start by doing a IP config to look at our IP configuration. We see we've got a default gateway of 172.16.0.254, which we can reach. So we know that this PC can go through the switch and up towards its default gateway, and we now have given it via RIP a route to the 172.168 network. PC3 has a route back to its default gateway, and its network or its edge router knows how to reach the 172 network. So hopefully now we may have some kind of end-to-end reachability. Let's give it a moment and we'll see what we get back. So there we have it. Okay, so that's all we've got time for. Just to recap on what we've done. We first of all had a look at dynamic routing. We said that it's a little bit different to static. In static routing, you say to a particular router how you would reach a destination and where you go to get to that destination. I.e., if you want to get to the 192.168.00/24, go to 10.0.0.1. In dynamic routing, that's not the case. You have a bunch of routers. Those routers are connected either directly or indirectly through a switch, and then you enable the routing processes on the interfaces, and then they're able to either form some kind of neighborship or adjacency or send dynamic updates to one another. We've done RIP in this video, the routing information protocol, which is the main routing protocol that you need to be aware of for your ICND1 and CCENT. But you'll see that as you progress through your career and through your studies, that other protocols like EIGRP, OSPF, BGP and so forth isn't as straightforward as RIP. RIP, you enable it and they just send a bunch of updates out. EIGRP, OSPF, BGPs, these create some sort of neighbors, adjacencies or peerings with one another in order to exchange routing information. We said that different routing protocols have different administrative distance and in turn different metrics. We briefly touched on why that's needed. We said it primarily comes back to path selection, and it's one of the reasons why we as engineers get a lot of options, and it's also one of the reasons why routing can become so complex. We configured RIP in a small network, very similar to what we've done with our static routing, and that was to give us a feel of how dynamic routing differs from static routing. And we had a look at why it may be better. Obviously with dynamic routing, if a link goes up or down, the routers will accommodate and may use different paths. Whereas static routing, it may not identify the link's gone down correctly if you're not using any sort of track statements or IPSLA. But even if you are, dynamic routing gives you a lot more flexibility and options to prefer and pick different paths in different scenarios. In the next video, we'll jump into understanding the path selection and routing decisions that's made on a per hop basis in more depth. I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.